Welcome, and today we will be taking a quick look at one tool I ignored in my previous videos. Some people have noticed it. There is, with the BadBoy release zip, another emulator called SweepEmu. And this emulator is different. It helps you reverse engineer without knowing exactly what things are. I just dive into it. That will probably be the easiest. This is one here you can just double click. You don't need any command line tooling. We're just going to the Ninja Gaiden Shadow because that was what we were looking at. Selecting the ROM. Doesn't matter if you take the original one or the compiled one. And we have an emulator. It's a very basic one. Just have the usual buttons with A, S for A and B, and Enter and Shift for start and select. I can play here. As normal, I have save states, so I can press F4 to save a state, F2 to load a state. And that's an important thing for what we're gonna do. Well, I'm gonna restart this because one thing I want to look at, if we take our other emulator, the most awesome one we have, and look at how initially I'm quickly opening the debugger with escape, opening the VRAM viewer with F5, then letting the game run. I see that the original logo is loaded, and after that directly the graphics of the intro are loaded. So I want to know a bit more about those graphics. Last time when we looked at the ROM in the image, I had the suspicion these graphics are loaded from here. Why? These look a bit like the intro graphics. I don't know exactly why. I just have that feeling. So that's something we're gonna look at with the SweepEmu. And what the SweepEmu does is it. So now I'm gonna set a save state at the end of this logo, and then as soon as the evil guy here shows up, I'm gonna press tab. This pauses the emulator, and it now stored the state between the moment I made the save state, which was at the start showing logo, till here. And I can say, okay, I wanna modify the ROM. So we're gonna modify the ROM, and we're looking at, if we go back to the graphics, export, bank 6. So I'm gonna type here bank 6. This is just using arrow keys. This can change with up, down, but also by entering numbers. Bank 6 starts at 4000. Let's target up to 4600. 4600. And what I'm going to do is for each of these bytes, add 1 to the byte in the ROM. And then we're going to press enter. And now what it's going to do is go over each of these bytes and modify it, that specific byte, just adding 1 value to it, running from our save state until we press tab and record the result. And we see some graphical glitches happening. So my suspicion of being graphics there is correct. This will take a bit, as you can see. It's only up to 100, and we ask it up to 600, so it's gonna take a while. But we see that these graphics now glitch out. So changing one of these bytes affects these graphics. So it's clearly something graphics related. But sometimes small bits modify, sometimes bigger bits, sometimes multiple bits. sometimes multiple tiles, 8 by 8 tiles. You should know if you read the band docs, and you have read the band docs, because I told you so. So there's clearly some kind of compression going on. What kind of compression? It's hard to judge from just this, but we can already immediately see that there's some kind of compression going on just by seeing how this behaves. If it would only modify one line at a time, there would be no compression or very simple compression. But here, because sometimes it's affecting whole blocks, it's clearly some more advanced compression. So, and it's not just that we can see this here. If we go to our folder where we are running the emulator, so where the ROM is, there it created an output directory, and there we modified the ROM from address 6, from bank 6 4000 to 4600, and it's generating here a ton of images. So, and an HTML file. Easiest to open the HTML file. We can just look at that and see this is the first picture, and if we hover over it, we get a tooltip. This is the reference one, so this is without any modifications. And then here we see an image where it added one, and we hover over it and we get a tooltip. It says 4006. It added one, and then was the result. And it only stores the result in this file if it was different. So up to like modifying 4000, 4001, 4002, 3, up to 05 didn't do anything, so they're not in this file. 4006 apparently caused the original intro logo, the text, to be loaded instead of the evil guy. And then sometimes it just does nothing. Also for each, like here, if I modify 4006, apparently it crashes or cannot load graphics or something. And next to the 4006 image, we have this black and like strangely colored image. That's the difference, because sometimes, as you can see here, like what's different between this image and this image, you cannot see, but here's the difference image, and then you know, oh, it's these lines that are these small blips and blobs that are modified. So occasionally you have completely corrupted graphics. So there's something going on here with compression. Diving into that compression is probably a complicated topic. So we can see if we even go later. So it's done now. It's run all the steps. So it gives control back. You can even modify, like I wanna don't add, but I wanna subtract one, or set it to a specific value, or XOR it, and you can change the value you want to add, subtract, or XOR, and you can do single or all. It means the all means if I detect a change, also do all other values of modifications. So if I say add 1 and it detects a change, it will also add 2, add 3, add 4. This significantly lengthens the runtime. So you want to do that over a small section. But you can get some more information about what a specific byte might be doing by just targeting a very specific section and saying, oh, I want all different values tested there. If you scroll more, we see other types of sort of corruption happening on the graphics. So this whole block that I targeted seems to be intro graphics related. How you would probably need to dive into disassembly how that's done, but now you could set a memory access breakpoint where this is accessed, and then you know where the decompression routine is. So just finding the graphics this way is already useful. I can use tab to switch back to the normal ROM, and continue running. If I enter the game and then I'm just here with an enemy, I'm gonna press F4. Yeah. So I've pressed F4 to save a state. Now I'm repeatedly pressing F2 to load it. So I'm taking a very short, just a few frames of input, because now I'm going to modify the memory, which starts at C000 up to E000, which is all the memory. I'm gonna add 20, just because I can, and do single. So this is just checking what happens if I run for a few frames on add 32, which is to each memory address. I don't know what will happen. I haven't run this before. I've checked the actually compressed graphics before, but I haven't done this. So I can do that the same for high memory as well. It starts at this and ends at this, which didn't seem to do much by the frames we've seen. But if we look actually at the output here, we can see if I take the HTML file. So this shifted, or this removed all the graphics, all the sprites, and corrupted them. It's probably the address for the shadow memory. So we can see multiple things happening. There's probably, like here we see suddenly completely different sprites. We see here, but I died. So each of those could be interesting. Same can be said for memory. Like, this is not that much to look at. Here suddenly we see the enemy jumping. So we clearly have at this address something enemy related. Once again, what it is exactly, you would have to really dive into it. But you might also see, oh, here suddenly an enemy disappeared, or the whole background disappeared, which is also funny in a way. Let's see if we see somewhere where just here the player got damaged. So there's probably some variable related to just, oh, I took damage. Or at least I'm in a damage animation, because it's not actually taking damage. Here we see, I think that the player moved forward. No, it's not. Could be. So this looks funky. So we can just look at these, and occasionally I'm seeing that there's like no difference here, which is weird. Like there's probably one pixel or something. I have to zoom in. I'm not seeing any difference. Anyhow, that's what you can do with this. It's very powerful. Very useful. Here we see the enemy turned around, so we probably have some memory location related to enemy direction. Because these enemies are silly, they just keep walking in one direction, if I remember right. So yeah, that's what you can do here. You can go in and label all of these in your disassembly once you figure out what they do. And that's it for now. I think this shows enough what you can do with it. And have fun with it. And don't like, don't subscribe.